One of the challenges with these medical problems is sorting through some of the vocabulary. And so I want to talk for a second about this stock standard. Stock standard is the concentrated version of whatever it is that you're working with. So in this particular problem, we have this concentrated stock standard, and we want to prepare something called a working standard. The working standard is the diluted version that we actually give to people. I think of this almost like chicken stock. So you can buy that super concentrated chicken bouillon, but you mix a little bit of it with water to make actual chicken stock. So the stock standard is like your bouillon, and the working standard is like your chicken stock in that metaphor. Sometimes it's useful to not make too much of the working standard. So in this problem, we want to make 50 milliliters of a working standard, and we want to have 20.0 milligrams per deciliter as the concentration. So reading this problem, we want 20.0 milligrams per deciliter of a creatinine solution. Don't ask me why. To prepare 50.0 milliliters of this working standard. So there's our volume that we want. This is the concentration that we want. How many milliliters of the stock standard with a concentration of 2.5 milligrams per milliliter of creatinine is needed? So, and there's a hint, let's look at the units. So one of the things I notice is I'm looking at milligrams or milliliters, and then all of a sudden this DL, that's deciliters. And so let's change that deciliters to milliliters so we're all working with the same thing. So we have 20.0 milligrams per deciliter. For a deciliter going to milliliters, I know that there's 1,000 milliliters in 1 liter. And I also know there's 10 deciliters in 1 liter. So bringing that together, I know that there's 100 milliliters in 1 deciliter. Okay, so 1 deciliter, 100 milliliters. So multiplying that fraction together, we end up with 20.0 milligrams per 100 milliliters. We don't need 100 milliliters, we need 50 milliliters. So if we start with 20 milligrams per 100 milliliter, and we want to end up with 50 milliliters, how many milligrams are we going to need? Well, I can just reduce this fraction by a factor of 2 over 2. And so this ends up becoming 10 milligrams over 50 milliliters. And how I did that was I just looked at half of 20 is 10, because half of 100 is 50. Since 50 is what I wanted to end up in the denominator, that's how I knew to reduce both by 1/2. Okay, so what this means is that we need 10 milligrams of the reagent, or 10.0 milligrams of the reagent, the creatinine, in order to make 50 milliliters of the working solution. Here's where this last bit comes in. I know that the stock solution is 2.5 milligrams per milliliter of the stock solution. So if I need 10 milligrams of that, what that means is that 10 milligrams equals some number of milliliters times the 2.5 milligrams per milliliter that the stock solution currently is. So I'm setting it up this way, and the units again are helping me because I know milliliter and milliliter will simplify out. This is how I end up with milligrams. So with just numbers, no units in there, this is 10 equals x times 2.5. So to solve, we just divide both sides by 2.5. And we end up with 4. This is x. X was supposed to be milliliters. So 4 equals x, which means we need 4 milliliters of the stock standard. Thank you.